All right, so this is what we're doing. So what we're going to do today, we're going to talk about something that we've already done, but it's kind of part of something that we've already done, but you maybe haven't noticed something about it, and I want you to notice that thing, because noticing the thing that I want you to notice is going to be useful to you. So instead of just telling you what that is, I want you to notice it on your own, and then it'll really stick, and since you found it on your own. So it's going to be a little different today. It's not a very long lesson, but I'll give you time to try to find it on your own. Okay? So this is what you're going to do. You're going to look at 3 sets of graphs and equations, and you're going to notice things. And it might take you a few times of scrolling through them to notice, then looking at the other ones, then looking at the other ones. Okay? You're going to have 3 galleries: a pink gallery, a blue gallery, and a yellow gallery. All the graphs in the pink gallery have a couple things in common. Well, I should say all the equations and graphs. All the blue ones have a couple things in common. All the yellow ones have a couple things in common. So to find them, you go to OneNote and go to Lessons, and then the last lesson is today, and then you just go to the pink, the blue, and the yellow. So for instance, maybe you're looking at the blue. You would go through and take a look at this graph, take a look at the work that somebody would have done with the quadratic formula. Then you look at this graph and the work that somebody would have done with the quadratic formula. And this graph and the work. And notice a trend. Try to find something that is true about all of them in both the equation and the graph. And then take a look at the pink one and the yellow one and do the same thing. And sketch, just pick one of the graphs to sketch, so you'll have an example in your notes, and then try to answer the questions underneath that are asking for you to notice these things, okay? As you're going through it, if you think you're onto something but you have a question, ask. I will be happy to pop around in the rest of the classes today. There's some really good questions like, wait, what does this mean? Is this what you're... And people were able to get to where we were hoping, okay? And then we'll summarize and we'll define what it is that we're talking about at the end. But I do want you to try to figure it out on your own, okay? Okay, I've gotten this question in every class. Roots. Maybe we haven't used this word enough. Roots are x-intercepts unless they're imaginary roots, right? Roots are really just solutions. They're solutions to a quadratic. A lot of the time that is the x-intercepts unless they're imaginary roots, and then we don't have any x-intercepts, right? So roots, put it this way, if your roots are real, yep, you can find your x-intercepts, and those are your roots. If your roots are imaginary, you need to find them algebraically. You need to use the quadratic formula, okay? So your roots can either be found on the graph, or if they're imaginary, you need to look elsewhere. All right, are we ready? Want to talk about it? Okay, so we're going to start with the blue, okay? And there was 2 things I wanted you to notice, and I put up an example of the blue. I just picked one of them, right? There's a couple things that the blue graphs all had in common. What's one thing? Well, I should say the blue quadratic equations, graphs, and formulas had in common. What was one thing they all had in common? What do you think? They all had the square root of 0. So they all had this square root of 0. When you did the quadratic formula, you got a square root of 0 in there. Okay. And then what else did they all have in common? What did you say? They're all right on the x-axis, meaning they have one real solution. So they all have one real solution, and they all had a square root of 0 when you did the quadratic formula. So what does that mean? What do you think we can take away from that? If you have a, yep, plus or minus square root of 0 will give you one real solution. And before we move on from this, anybody know why that happens? Why do you think that will always happen?
Because number multiplied by 0.
Well, it's not multiplying, it's adding, but you're close. Yeah.
Is it because only 0 goes into 0?
Kinda. Think about what plus or minus means. Yeah.
You're adding or subtracting 0.
You're adding or subtracting 0. Is that going to change anything? No. So it's 6 plus 0 divided by 2. That's 6 divided by 2. That's 3. 6 minus 0 divided by 2. That's 6 divided by 2. That's 3. It's the same answer twice. So if you're plus or minusing 0, you're not going to change your answer, so you get one answer. In every other situation, you're plus or minusing a number, so you're adding 4 and you're subtracting 4. Those are two different answers, right? If you're plus or minusing 0, you only get one answer. So if you get a square root of 0, you're going to have one solution, one x-intercept, one real solution, right? Let's go to yellow next. All right, so yellow, right? What are the two things along the same lines that they all had in common? All of the equations had this in common. All of the graphs had this in common. Yeah?
They didn't have any x-intercepts.
No x-intercepts, right? So what do we know about when an equation has no, what do we know about the roots when there's no x-intercepts? There's no real solution, so there are two imaginary solutions, right? Two imaginary solutions. If you wrote 2I solutions on a test, I would know what you meant. And then what else did all of them have in common when somebody tried to do the quadratic formula? They all had a negative square root, right? So they all had, well, that's not going to show up. I'll have to do this in green. They all had a negative under the square root, okay? Which brings us to our first one, but our last one. What did all of the pink ones have in common? Two things. Two real solutions, right? We know that because they had two x-intercepts. And what did all their square roots have in common? It's a little harder to see, which is why we did it last, but what do we think? Yeah?
Have nice even numbers.
Well, some of them did. Some of them had like square root of 36, which was nice, but like I think one of them was like square root of 50 or something like that. 53. Yeah, so it doesn't have to be a perfect number, although we'll talk about what it means if it is. But think about it. All the imaginary ones were? Negative. All of the one solution ones were? 0. What's the only thing that's left? Positive. So if you have a positive under the square root, right, you know that you'll have two real solutions, right? So that's our takeaway, right? And that is something that actually has more use than just that, okay? So we're going to now go into like defining what we just talked about, and then we'll be done, and you can work on your homework and whatever else, okay? So flip to the back. Okay, so we all have been dealing with this quadratic formula, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Some of us like it, some of us don't love it, but wouldn't it be useful to know, am I going to need to use this thing, or like, can I factor instead, right? And this what we're about to talk about can help you use it when you want to and avoid it when you don't. Or at least know when you have to, okay? So what part of the quadratic formula did we just talk about it? Like, what part did we just focus on every time? The part under the square root. We didn't even care about the square root part. It was like the number underneath it, right? Was it positive? Was it negative? Was it 0? So that is right here, right? So this is what's called the discriminant. B squared minus 4ac. And you could even say like Some people even say D equals B squared minus 4AC. That's called the discriminant. And just by doing that part, you learn some things, right? So there's three situations here, right? There's if B squared minus 4AC is greater than 0, what do we know? If that number under the radical is greater than 0, we know there's two real solutions. If B squared minus 4AC equals 0, we know there's one real solution. And then if B squared minus 4AC is less than 0, we know that there's two imaginary solutions. Okay, so that's useful to know if we're making predictions, right? But there's a little more here. Let's talk about 0 for a second. When I had 0, right, and I had 6 plus or minus 0 divided by 2, what kind of number did I get there? Like when you have 0 and the plus or minus goes away and you get, didn't I get like a nice number? Yeah. So if you have 0, like you could factor it. You could have factored it. You don't need the quadratic formula. So 0 means factorable. It means you can stop doing the quadratic formula if you want to try to factor the thing, if you don't like the quadratic formula. Okay? Now, you said something about nice numbers before. Okay? So think about if I had a nice number. Like, think about if I had like 10 plus or minus the square root of 36 over 2. Right? What do you call a square root? A what? A perfect square. So let's think about that scenario. Perfect square. So if I did B squared minus 4AC and I got a perfect square, what kind of answer am I going to get? A crazy one or pretty nice one? This would turn into 10 plus or minus 6 divided by 2, which is 16 divided by 2 or 4 divided by 2. Two pretty nice numbers, which we always get when we factor, right? So again, perfect square, if it's a perfect square, it's factorable. Right? Why is that useful to know? Well, let's say I don't like the quadratic formula. I don't want to do the whole thing. I make mistakes sometimes with it. I want to test whether or not I can factor. I'm at the rainbow method. I'm at reverse box, and I can't find the combination. And remember I said you don't know if it's because you can't figure it out or because it doesn't exist. And you want to know, right? This will tell you. Just do B squared minus 4AC. Find that number. If it's a perfect square, the numbers exist. You can factor it. Keep trying. If it's like 17, you're going to need the quadratic formula. Okay? If it's 0, try to factor, right? Because you probably can, right? If it's a negative, well, you definitely need the quadratic formula. It's going to be imaginary solutions, right? So just knowing this one piece, the B squared minus 4AC, saves us from having to do the whole quadratic formula, and it tests what type of situation we're in, right? And a lot of students find that useful, right? Because they want to be able to avoid the quadratic formula if they want. Now, for your quiz, all you're going to need to tell me is 2 real solutions, 1 real solution, 2 imaginary solutions. But if you get good at this, you can use it to help you, okay? All right, so all I want you to do now is practice with a few of these. So for each of these, it just says find the discriminant. That's not telling you to solve. I literally just want you to say, hey, B squared minus 4AC equals something, and then tell me what does that mean for each of these. And the other thing I will say is you have to be equal to 0 to do this. You can't have numbers on the other side. So if something's on the other side, get it equal to 0 first, then pull your values. Okay? So remember, b squared minus 4ac, your calculator is your friend. Like, it's great that you want to be able to do it, but there's a lot of opportunities to make mistakes, so that you can just plug in b squared minus 4ac into your calculator, press enter. Yeah? Yep. All right. So I just want to go over the results here so we can make sure we have our takeaway. All right. So what was this one? B squared minus 4ac. What'd you get? 4. Square root of. We don't square root it. We're just looking for that number underneath. And because we know it's positive, we know we have 2 real solutions. And then also, yeah, we could use magic X on this, right? Because it's a perfect square. So that means I'm in luck. I don't need to use a quadratic formula. All right, here, b squared minus 4ac was equal to what? 0, which means 1 real solution. And what do you think we might be able to do with that equation? Yeah, I can GCF it and see how that goes, okay? Now here, I would want to add 10 to both sides, and I get x squared minus 6x plus 10 equals 0. So I get the right c value. It would be a positive, right? And then I find out that b squared minus 4ac equals negative 36, which means 2 imaginary solutions, and it also means I need to use what? The quadratic formula. There's no way out of it. You're using it. Okay? I don't know. Is it not negative 36? What is it? It's negative 4. I didn't check my work on that one. I was just trusting you. Okay. Yeah, that sounds more familiar. All right. Now, one more thing, and then we'll be done. What if I got, like, 17 here? 2 real solutions, but can I factor it? No, I got to use the quadratic formula, right? So there's 2 scenarios where you got to use the quadratic formula. A positive non-perfect square and a negative number. Otherwise, you can try to factor it, okay?